Hello everyone, today in this video we'll be discussing the third module of CG, which is regarding the clipping. Okay, so we have totally 3 chapters in it. Fine. So let me tell you the brief overview of this module and what you need to focus upon, what is asked mostly in exam, and we'll be going through the previous paper as well, so to get a brief means a better information regarding what type of question could be asked and how to solve them. Okay, and the theory concepts, how to keep in mind, what are the key points. Okay, so these are the things which we'll be discussing in this video, but before that we need to know what is the syllabus, right? Because if we don't know the syllabus, we'll be simply reading something and wasting time, right? So first we need to know what is the syllabus. So this is the first chapter, which is clipping. Okay, so clipping has clipping window, normalization and viewport transformation, clipping algorithms. In clipping algorithms, two of the most important algorithm is Cohen-Sutherland line clipping and Sutherland-Hodgeman polygon clipping algorithm. These are the two very important algorithms. The questions are asked from these two topics. Okay, and these are just the theoretical concepts. So we'll go through the theoretical concepts briefly, and then we'll be learning these two algorithms, how to solve means the procedure for it. Okay, so that will cover up the module, the first chapter of module 1. The second chapter is the 3D transformations. So here we have a lot of numerical concepts. Okay, so a lot of numerical concepts are here, so we need to go through it, as well as the theory concepts, like they'll tell you to mention the what is affine transformation or what are the different composite 3D transformation. So you have to give an example and write the formula for it and write the element diagram for it. Okay, so that is in the 3D transformations. Then finally, coming to the last chapter, where we have illumination and color. Here are some of the theoretical concepts. So looking what are the theoretical concepts you need to keep in mind and what are the most repeated ones. Okay, so those are the things which we'll be discussing in this video, and let's get started with the video. And before starting, if you like this video, hit the like button and don't forget to subscribe to my channel. Now let's jump to the question bank. So module 3 important questions are: explain clipping, clipping window and viewport transformations, then derive 2D line clipping algorithm, Cohen-Sutherland line clipping algorithm, and derive polygon fill area clipping. These are the two important algorithms. You can be asked with the algorithm as well as explain the algorithm along with the relevant example, or you can be asked the problem as well. Okay, so 3 things can be asked under these 2 questions. Explain clipping, clipping window, viewport transformation. It's a theoretical concept. You need to know what is clipping window, you need to know what is viewport transformation, what do you mean by that, and explain with an example. Then we have the Cohen explain Sutherland-Hodgeman polygon clipping algorithm. So this is just the extension of this one, polygon area fill area clipping. So this algorithm will be used for doing the polygon fill area clipping. So that's why they have mentioned here. And derive 3D geometry transformations. See, they can give you the question like this: derive 3D geometry transformations. This is the second chapter, and in that you have to define the various 3D transformations which are present in the module, and by giving the matrix values and the relevant examples. Or they can ask like this: 3D translation, rotation and scaling. So for each you have to write the formula and what it does to the diagram before and after, that you have to mention. Then what are affine transformations? You have to write the theoretical concept, and with the matrix values means the equations you have to write. And after that we have differentiate color models, RGB and CMY. What is RGB? Red, green and blue, and CMY is cyan, magenta and yellow. Okay, so you have to define these 2 things, what is the difference between them and how do they differ from each other, that you have to mention. Okay, then explain the illumination models, light sources. What are the different models in light sources? There are 3: ambient, radiation and spectacular, something it's there, so I'm not remembering that, but that is the thing which you have to explain if they ask this question. And finally we have derive Phong models. Okay, so we'll be discussing that as well, what is Phong models, and that marks the end of the module 3. Okay, so these are the topics which you need to keep in mind. Let's get started. When going through the topics, I'll be mentioning these are the key points, so you have to mention that in the exam sheet. Okay, so let's get started with the first topic, which is clipping window and the viewport transformation. Before that, I forgot to share this one. This is the means question bank. So let's go through it first to get to know what is the thing we need to focus more upon. Okay, so in module 3, design a transformation matrix for the window to viewport transformation. Explain how the reshape function works in OpenGL programming. Window to viewport transformation is asked here. Okay, so that's the first topic, viewport transformation we are going to study. That's the same thing which is asked here. Okay, with the help of a suitable diagram, explain the basic 3D transformation techniques. Give the transformation technique, transformation matrix. Okay, basic 3D geometric transformation you have to mention. What are the different types in it, just as how we did in 2D transformations, same thing you have to do in the form of 3D. Okay, and as well as you have to give the transformation matrix and explain with the example. And here they have asked the meaning of affine transformation, so you have to give the definition and the matrix values, and the equations are there. Okay, that you have to give. With the help of OpenGL statements and diagram, explain illumination and shading model. This from the last or second last topic. Here you have to explain these 2 things with the help of OpenGL statements. Means how do you implement this topic using OpenGL, that you have to explain. Okay, what is clipping, and explain the Cohen-Sutherland algorithm with the suitable example, the important topic. Explain 3D transformation to rotate a 3D object about the axis that is parallel to one of its coordinate axes. So there are different types of 3D rotation. There are 3 types of 3D rotation. We'll be discussing each one by one, and the numericals associated with that, and what do these terms mean, and how they differ from each other. So whichever they ask, you have to specifically write about that. Okay, so we'll be discussing that in the 3D chapter. And with the help of a suitable diagram, explain the illumination, RGB and CMY. You have to differentiate between these two. So that was in the first paper. Let's see what is in the second one. What is clipping? Explain the Sutherland-Hodgeman. See, those two are the very important algorithms, Cohen-Sutherland and Sutherland-Hodgeman. Okay, these are the two important algorithms in the chapter 1. Explain basic illumination models, the last question. Differentiate between RGB and CMY and transformation between them. Explain the matrix representation for rotation of an object about arbitrary axis. This is another type of rotation that also we'll discuss. Then in the third paper, what we have, so this is the clipping. Explain the Cohen-Sutherland clipping algorithm and Phong lighting model. Clip this using Sutherland-Hodgeman Polygon. So we'll be solving these type of questions, so that if the question like this question comes, then what are the steps you need to follow to reach the final solution. That also we'll be discussing. Okay, explain the different type of light sources supported by OpenGL and what is RGB CMY. Okay, RGB CMY is mostly asked in all the previous year papers, right? As you can observe here. Here what we have is explain Cohen-Sutherland line clipping algorithm, and this is the numerical. Okay, so before they just add that means the algorithm along with an example. Anyway, if they give example, you anyway have to take these values and do, right? Now they have given the values, you have to do the same thing. So this is very important. Cohen-Sutherland, you need to know the algorithm and it's working, and with an example explain. And if they give the example here, means the values they give, you have to draw this and get the final output. Okay, same thing goes with the Sutherland-Hodgeman also, like this they will give. Okay, define color model and explain the RGB and CMY. See this are here also. And specular reflection and the Phong model. Phong model is the last topic. Specular reflection is one of the illumination models. So they have asked specifically this one to explain this one only. Then what we have is the clipping. Explains Sutherland-Hodgeman basic illumination model, RGB, CMY, matrix representation about arbitrary axis. And here also is the same thing. I guess this is the same question paper. Yeah, this is also discussed. Yeah, this is also discussed. So you got to know, right, what are the important topics. So those things we'll be discussing as we go through the means video. I'll be telling you what are the things which are important and you need to pay attention to. Okay, so let's get started with the first topic, which is clipping window and viewport transformation. So module 3 starts from here. The first topic is the clipping window. In that we have the two more topics, clipping window and the viewport transformation. So what is a clipping window? If I explain you briefly what is a clipping window is, you already know what is a clipping window, right? See, if this is the whole window and if you just want to display this part of it, this part of the window, that is known as the clipping window. You're just cropping the window into smaller size. Okay, that is known as clipping window. And yeah, that's all what you have to mention about if they ask you what is a clipping window. You can go through these points to get more information and key points, but that's the main topic. Okay, viewing coordinate clipping window. Okay, so clipping window can means it's not just like it will be x-axis, y-axis, it can be in this way also, right? So it will be defined in its respective x-axis and y-axis. Okay, and v is called the view up vector. And what is v is, we choose an origin for 2D dimensional viewing coordinate from some world position x0, y0. We can establish the orientation using a world vector v that defines the y view direction. So if with respect to this axis, how much is this axis, that is defined by the va vector. Okay, that is view up vector. And here are some more theoretical concepts, like in perform the translation and the rotation, and when you do the both of the things, it will be like M matrix, WC is world coordinates, VC is view coordinates. Okay, also we have to include the unit vectors, so that is represented by u, ux and uy, and the unit vectors v, which is vx and vy. Okay, so yeah, that's all what is there in the first topic. And here we have like this, just the visualization of the thing, right? See, this is the diagram we had here. It got translated to here, and then we will be rotating this one in this direction, and then we will be again translating it back, so it will look like this in the final diagram. Okay, and world coordinate clipping window, this was about what? This was about the viewing coordinate clipping window. So this is about the viewing coordinate. If they ask you, have to write this one. If they ask you about the world coordinate, then what you are supposed to write is this one. Okay, you'll be just transforming the diagram directly into the world coordinates, because there is no more another axis, because in the world coordinate only we will be doing the x and y thing, so that will be directly done here, and the clipping window is defined here itself. Okay, and normalization and viewport transformation, this is a very important concept. Okay, how to from world to viewport transformation, how do you do, that's discussed here. Okay, so suppose that this is the point here, and suppose that you are in a phone, like I can show you here itself, right? If I zoom this out, this picture become very small, right? This picture become very small. Remember this size, okay? This size what I have drawn here. Now see, I have zoomed out. In the same place I will keep and draw that. This much only I had drawn, right? So that is known as normalization. Okay, just cropping it out. Okay, so this point it was present here, in the same ratio it will be present here, it's here also, and the length will be decreased in the same ratio, and everything will be done in a normalized form. Okay, so here are some of the means equations that you have to memorize, right? After that, writing the diagram, you have to write these things. So this is what you will to transform the world coordinate point to same relative position within the viewport. So to transform the world coordinate to the viewport within the same point in the same position, we will be using these formulas. Okay, and for this we will be using the scaling factors. You will calculate as follows, and translation factors will calculate as follows. Means how much scaling is to be done, how much translation is to be done, that we will calculate in that way. Okay, and yeah, this is in the matrix form, it will look like this, and if you do both together it will look like this. Okay, so mapping the clipping into a normalized square. So for this also there are some formulas. What you will be doing is, you have a point here, you will be normalizing it into a square here, so the screen viewport finally it will look like this. For that also here are some matrix values, you can go through it, and these are things which you need to write after you go through the world means if they ask you this question from world coordinate to viewpoint transformation, how do you do, you have to write these things along with the matrix values. Okay, so that is there in the first chapter, clipping window, sorry, not first chapter, the first topic, which is clipping window and viewport transformation. Okay, after that we have the few means two more concepts, which is display of characteristics. Means if you type in the keyword ABCD and it has to be displayed on the screen, how it will be displayed is each pixel will be illuminated based on the bitmap values. Okay, that's what it's mentioned here. Split screen effects in multiple output devices. If you want to show your selfie in 3 different devices together, your 1/3 face will be here, and 1/3 face will be here, and 1/3 face will be here. So that is how the means what all should happen, what all should display here, and what is the size of the device, based on that also it will differ. Means it should not be zoomed less here and zoomed more here, it will look very weird. So you should have that scaling transformation, right? That happens by clipping window from world to viewport transformation. So that's what is mentioned here. Okay, so these are the optional topics you can mention if you know about these things in the answer sheet. Okay, but the main thing what you have to mention is about the matrix values. Okay, matrix values you have to mention, and this diagram you have to make, and there is a transformation diagram, and the equations you have to write. Okay, scaling factor and the translation factor equations you have to write. Okay, and also write some theoretical concepts, means what does it actually mean, and that will be sufficient for answering this question. Okay, the clipping window and the viewport transformations. Let's move on to the second topic, which is regarding the two-dimensional line clipping. So here the two-dimensional line clipping, they are totally clipping algorithms, means we will be using the algorithms to clip it. Okay, means if this is the total image like this. Okay, if you want to clip it in just this way, okay, what all will be displayed finally is this line was here, right? So it will be just displayed like this, and this line was here, right? It will just be displayed like this. This line was here, it will just be displayed like this. So this is the final output I want. I don't want these things, I should remove these things. So how do I know where exactly I should remove, and which is the intersection points, what is the slope of these things, so that I can calculate the intersection points? Those things we'll be discussing. There are some algorithms. There are 2 algorithms for the clipping. One is for the line, and another one is for the polygon. For the line it is Cohen-Sutherland, and for the polygon it is Sutherland-Hodgeman algorithm. Okay, so let's discuss each one by one. So this is the first topic, which is of the problem type, and that is about the Cohen-Sutherland line clipping algorithm. Okay, so we'll be discussing what it is and how do you solve it. Okay, so if the points are given like this, means there are many lines here, right? And this is the clipping window. If you clip it, at that time the final output will look as follows. So how do we know which points you have to clip and what are the points you have to crop? Okay, so that's what we are going to do in this problem. Okay, so let's see. There are 4 cases in it. Okay, the lines can be divided into 4 cases. Both the points are outside the plane, means the clipping window. Both the points are inside the plane. One point is outside, one point is inside, and one point is outside, both the points are outside but it is passing through inside. Okay, these are the 4 cases which can be which we can come across, right? So we'll be looking at each case how to solve. Okay, means if it is in this case, what we will do is we will just remove the whole line, because it's not in the clipping window, right? If it's inside the plane, we will keep it as such, and if it's one point is inside, we will find out what is this point and we will keep this much part only, and in this case we will just remove this part and this part and keep this much part only. So you need to know the region codes. Region codes is very important. Okay, so region codes is as follows: top, bottom, right, left, I guess TBRL or TBLR. Yeah, it is TBRL. So in TBRL, you will, when you divide the whole plane into 4 parts, each part you can see what is this called as, this is top left, right? So top and left will be 1, rest will be 0. This is what, this is just top, so top will be there. This is top right, so top and right will be 1. This is what, this is left, so left only will be there. This is middle part, so it is nothing, so all zeros. And this is the right, so this will it will be just right here. This is bottom left, right? So bottom and left will be 1, and this is bottom, so bottom will be 1, and this is bottom right, so bottom and right will be 1. Okay, so this is the thing which is the first thing we need to know, region codes. Now based on region codes, we will be finding if the line is which it's lying inside or outside or half inside or outside and inside that it is present. So we will be seeing how to do that. Okay, and divide the whatever lines are given, just divide it as follows. Divide this in this way, then consider each line at a time. First let's consider P1 P2. So P1 P2 lies in which region? This region. What is the code for this one? The code for this one is 0001, right? 0001. So for P1 also write 0001, for P2 also write 0001, and if it is non-zero, yeah, it's non-zero, so write here non-zero. This is also non-zero, write non-zero. Perform the AND operation. When you perform the AND operation, what answer you get? That is also non-zero. If that's the case, then write non-zero. So what's the solution you get from here? What's the observation we found here? 2 non-zeros and another non-zero. If both the endpoints are non-zero and we get the result of AND operation also as non-zero, we say that the line is completely outside the clipping window. So the line is completely outside the clipping window. That's the observation we get from here. Next we'll consider another one, P3 P4. Both is inside the window. Let's see what it is. What's the code for it? And for all 4 zeros. So if you write for P3 and P4 all zeros and find out the AND operation, it will be still 0. If both are 0 and it is 0, line is clipping inside the window, no clipping is required. It is present inside the window if all is zeros. Okay, now comes the third point, which is P5 and P6. So what is the code for this one? Let's see that. This is 0 0 0 0, and what about this one? This is top, so it will be 1 0 0 0. So let's write down here 1 0 0 0 0 0, and if you find out the AND operation, it will be 0. If one of them is non-zero and the second one is 0, then you get an answer as 0. That means it should be partially clipped. Let's find out the last one. It is P7 P8. So let's see P7 P8. So P7 P8 is 0 1 0 0 0 0 1 0. Okay. This also answer we get as 0 0 0 0. So if 2 non-zeros are there and we get answer as 0, that's also partially to be clipped. Whenever we get the answer 0, that means it is to be clipped, except for the first case, which is it is in the middle part. Okay. Now if we have to clip this one, at that time what we have to do? If we get both non-zero values but the final answer still is 0, at that time we have to clip from both the sides, right? What I mean is we have to clip from both the sides. You have to find out this value as well as this value. Okay, so how we'll be doing that? We'll be using this equation here, this equation as well as this equation. I'll tell you how these equations are derived. So for that, what we need to consider is an example here. Okay, so yeah, let me tell you an example before this one. So if this is a point here, okay, let's consider a point here. This is 10 comma 10 and this is 30 comma 30. I've drawn a line here. Okay, what is the slope of it? Slope is just 1, right? Because y2 minus y1 by x2 minus x1, right? That is 1. Slope is 1. Now if I have to find out a point here, okay, I know the value of y value. Y value is 25. Y value is what? 25. And x value I don't know. So this point I can represent as x comma 25. So what I can do is 25 minus 10 divided by x minus 10 is equal to 1. 25 minus 10 by x minus x minus 10 is equal to 1, because slope is this one, this is defined as slope. So if I know one of the values, I can find out the second value using the slope. At each point I can do the same thing. If I know this, I can find out this. If I know this, I can find out this. Reverse is also possible. So what you can observe is, if I know the m value and I know one of the points, I can find out the second point. That's the same concept what you will be using here as well. I know that it's clipping here, it's intersecting at this point. One of the values I know. Also, by using this value and this value, I have already calculated the slope of this. If I know the slope and I know one of the points, I can easily calculate what is the next point which is intersecting here, which is exactly this point here. So that's the same formula which we are using, just in a different form we are writing. See, if you just resubstitute this one, y minus y1 divided by x minus x1, that is m. So since we need the y value, we are just writing y is equal to y1 plus m into x minus x1. That's all. Just use this logic to find out the answer. You need not memorize the formula also. Okay. So this is the type of the question. We will be discussing one question under this topic and moving on to the next one. So the question can be of this type. Let ABCD be a rectangular window with A 2020, B 9020, and C 9070, and D 2070. So this is the rectangular window which has ABCD values given to us. Find the region code for the end points when using the Cohen-Sutherland algorithm to clip the line P1, P2. So first we have to find out what is the region codes of these 2 points. After that we have to clip the line. These P2 and P1 and P2 values are given. We have to find out this intersection point, this intersection point. So let's see how to approach this one. Okay. Actually it's not drawn properly because 1030 is given here and 1030 should be actually here. So picture will be actually like this. That's all right. We already know, means it doesn't make difference. We just have to know what is the working of it, right? So this much point is understood. Now we will find out the region codes. In the region codes, this was 1000 because it's top, and this point was bottom left, right? Bottom left means 0101 TBRL. So 0101 and 100, if you find out the AND operation, what you get is 0. If you get 0 for the AND operation and both are non-zeros, what I told you, you have to clip both of this. If you get a 0, you have to clip, and both are non-zeros means both the points you have to clip. Means where it intersects here, where it intersects here, that both you have to calculate. So first let's find out for P1. Okay. So P1, one of the values we know. Which is the value we know? Since this is the line which is intersecting, this line is going to x value which is 20. So I know for one thing 20. The second y thing y I need to calculate. For calculating y, I need to find out the slope. Slope between point P1 and P2. What is the slope of this line? 90 minus 30 by 80 minus 10. What is 90 minus 30? 60. And what is 80 minus 10? It is 70. So 60 by 70 or 6 by 7 is the slope. 6 by 7 is the slope. So after I have calculated the slope here, so I will be writing slope as m is equal to y2 minus y1 by x2 minus x1. Just write it in this form, because if you go with the actual formula, there is x max, y max, and x min, y min, also x1, x2, y2, y1, y2. So if you try to by heart, you will means there is much chance that you will get confused. So it's better to go with the logic part. So write it like this: m is equal to y2 minus y1 by x2 minus x1. Now what you need to find out is y value here. X value we already know here, right? So this is the point which I am trying to find out, and the slope is given to us as 6 by 7. Now 6 by 7 is equal to y2 minus y1. At this point, what is y2? I'm not sure about the y2 value because that's what I have to calculate. So I will be writing it as y2 itself. So let's make it more neatly. Okay, see here, observe carefully. The slope how much I got, so I will change the color here. Okay, slope how much I got, m is equal to 6 by 7, right? 6 by 7, keep in mind. And what is slope? Slope is equal to y2 minus y1 by x2 minus x1. Which are the 2 points we are trying to calculate the slope between this point and this point, right? This point and this point we are trying to calculate. So how do we do this is y2 minus y1 by x2 minus x1. That's what we are trying to do here, right? So let's substitute the values here. So what is the value of y2 and what is the value of y1? Y1 is the y value of this one So in the given question, the y value of p1 is, what is the p1 point given to us? P1 is given as 10 comma 30. So what is the y value here? 30. So instead of this one I'll write as 30. So y2 I'll keep it as y minus 30 by x2 minus x1. What is x2 value? 20 and x1 value is 10. So 20 minus 10, that is equal to 6 by 7. So if you do this one, you will easily get the value of y. Same thing you have to do here also. Here what you know, I know the slope which is 6 by 7 and I know the y value which is 70. So that is equal to which 2 points I am trying to calculate, between which 2 points? I am trying to calculate between this point and this point. So this y2 value is 90 here, sorry 70, minus what is the y1, so actually this is 90, right? Sorry, this is 90 minus 70 by, I am trying to calculate the x value. This x value here is 80 minus what is this value, x, that I am trying to calculate. So by doing this, you will easily get the value of x also here, right? So in that way, we will find out the value of x and y, and that's all what is there in the line clipping algorithm. So this is the final answer. You will find out the value of intersection points for P2. You substitute that value, x value you had calculated, and P1, y value you had calculated, that value you will substitute here. Okay. This is the second topic which is important from exam point of view, which is Sutherland-Hodgeman polygon clipping. Okay, Sutherland-Hodgeman polygon clipping. This is important from exam point of view. So here what we does is, let me show you the question how it is asked in exam. So this is one of the type of the question which can be asked in exam. So here you have a polygon, right, and you have a clipping window. Now if you crop it in this way means this way only, what will be the final output that you have to display in the screen. Okay, that's what the final result should be. Now how to know which points it is and what are the intersection points, that we will be trying to find out in this video. Okay, so before that you have to remember two concepts. Okay, two concepts you have to remember. The first concept is, what are the different type of polygons that you can form, means in out, out out, out in, or out out, and then the way in which we will be solving is left, right, bottom and top. So let's first start with the first concept, which is in, out, and means is it in or out. For example, see here, from V1 to V2 I am considering. Okay, V1 to V2. Now this is the diagram given to us, and this is the clipping window. Okay, now what I am considering is which edge is V1 to V2. V1 to V2, this is known as out, this is known as in. From V1 to V2, as you can observe, it is going from out to in, right, out to in. So if it is from out to in, at that time what I will write is V1 dash V2. The output will be V1 dash V2. I will write like that. If it is V1 to V2 and both is inside the triangle, I will just write V2, the ending point. If it is out to in, in to out, that means from V1 to V2 like this, then only I will write V1 dash. Then finally, if it is both outside, then I will not write anything. Okay, I will just discard that point. That's all. So how do you remember this is, start from here, you are starting from out, you are coming in. When you are coming in, this reflection gets stuck here, so it is V1 dash. Okay, like that you have to remember. If it is both inside, consider the last point. If it is both inside, consider the last point. If it's both inside, consider the last point. Okay, means V1 V2 is there, from V1 to V2 where you reach till end V2. Here you are coming where you got stuck and reach the end V1 dash. So that's why you have written V1 dash V2. Here you ended at V2, so you write V2. From V1 to V2, so what you are ending up at is V1 dash. You will just write V1 dash, and this both is outside, so you need not worry about that. Okay, this is the first thing you need to know. Second is left, right, bottom, top. Okay, left, right, bottom, top. So let's see one simple example, then we will move on to the complex one. Okay, so this is the triangle which is given to us, and the clipping area is defined as this one. Okay, this is the clipping area, and this is the triangle which is given to us. So first note down the edges. How many edges are there? V1 to V2, V2 to V3, V3 to V1. These are the three edges, right? So what is the sequence I mentioned you? L, R, B, T. Okay, left, right, bottom and top. If it is left, at that time what I will do is, I will draw a straight line here like this, and then I will consider this point as in point and this point as out point. Okay, this is out and this is in. Okay, remember I have divided this into this part, and this is in and this is out. Okay, now what we will do, which point we are considering? V1 V2. V1 V2 both are in, so I will just write V2 in the output. Next, V2 to V3. V2 to V3, it is from in to out. If it is from in to out, I will just write V2 dash. If it is from out to in, like V3 to V1, I will write V3 dash V1 in the output. After you have done that much, what is the sequences you have formed here? V2, V2 dash, V3 dash, V1. So that is the thing you will highlight in the next iteration. So this is the figure which you will be highlighting, v2, v2 dash, v3 dash, v1. Okay, so the next one is the right. Okay, so after you have highlighted this one, then you will be doing the right one. Right means make it like this, and then this is known as in and this is out. So anyway, there will be no difference because all is present in, it will be the same thing. v2, v2 dash, v3 dash and 1, v2, v2 dash, v3 dash and 1, again it will be the same thing. After LR it is B. B means bottom. Bottom means you will divide it like this, and then you will consider this part as out and this part as in. So whatever is in the polygon, that will be considered as in part and the rest will be considered as out part. So after you have divided this and considered this as in and this as out, at that time what you can find out? You can find out that what are the edges present here is, if you start from here, v2, we can start from v1. So yes, we have to start from v1 or v2, what they have done, v1. Okay, so we are starting from v1. Let's discuss v1 to v2, then v2 to v2 dash, then v2 dash to v3 dash, then v3 dash to 1. This is out, this is in. Now if you consider from here, it is out to in. If it is from out to in, it will be v1 dash here, right? v1 dash will be here, and this is in to in, it will be the same thing, it will be v2 dash. And this is from in to out. In to out means how it will be, it will be v2 dash, and here actually it will be v1 dash v2. Okay, because it is out to in, and this is from in to out, it will be v2 dash here, and here what we have is out to out, this we will discard. Okay, so what are the points we got here? v1 dash v2, so v1 dash is this one, v1 dash, let me change the color. So v1 dash v2, this is the first point, and here we got v2 dash, connect to v2 dash, then here we got actually this should be v2 double dash because v2 dash is already present, so this point is known as v2 double dash. So we'll connect this one, and then again the first one, which is v1 dash. So this is the point which will be getting in after the bottom. Okay, so that's what it's shown here, v2 double dash is here, v1 dash is here. So this is the point which will be getting after the bottom, and then we will be applying the top clipping, because top clipping doesn't make any difference because this is the point which we have got here. If we do the top clipping also, this all the parts will be in here and this will be out. Top clipping, it will also produce the same result. So the final result will be as follows. This is the final result. Write down the edges v1 dash, v2, v2 dash and v2 double dash. This is the final result after the clipping of this one from this triangle. Okay, that's our approach. Let's solve another question which is like the previous question. So here what we have is, how many edges we have? First note on that, A, B, C, D, E. 1, 2, 3, 4 and 5 edges are there. So start from A, B. Okay, A, B, if you consider the left edge, okay, left edge means we will be drawing like this. This is known as out, this is known as in. So in A to B will remain same, B to C will also remain same, D to E will remain same. From D to C to D will remain same. From D to E, D to E is from in to out. In to out means it will be D dash here, right? So I have written D dash here, and then E to A, it is out to in, so it is E dash A. So I have written E dash here. After that, join these two things, just clip out this part here. After that, you will be doing the right clipping. In the right clipping, what you will be doing after you get this figure, if you do the right clipping, this all will remain same. This is in part, just this will change and this will change. Here you will mark it as it is from this out, this is in to out, you will mark this as A dash here, and this you will be marking as B dash C. So A dash and B dash C will be marked here, and that will be cut off. Okay, A dash here and B dash C will be marked, and that will be cut off. After doing the right clipping, you have to do the bottom clipping. So if you do the bottom clipping at this point, these things will remain same, just the change will happen A, B, C, then from C to D and from D to D dash. From C to D when you go, it is from in to out, right? Because bottom clipping, in to out, what will happen, you will mark it as D double dash here. Okay, and when you go from out to in, you will mark as D, D dash, sorry, D triple dash and D dash. This will mark as D triple dash, right? But I don't know what they have marked, but that's what the point here. Okay, they have taken this as C dash. Okay, sorry, this will be C dash. Okay, because it is in to out, in is C, so it will be C dash, and this will be D double dash. So after the top clipping, what will happen? Sorry, this is after the bottom clipping I have to show. Okay, after the bottom clipping, this will be C dash here, and this will be D double dash, and then top clipping. Here where you are going from, in this way you are going, right? So E dash to A, it is from in, this is in and this is out. From in to out if you go, this will be E double dash, and from out to in if you come, then it will be A double dash, A dash, A double dash, A dash, right? A double dash, A dash. So yeah, that's all. E double dash here and A double dash A dash. So this is the final figure which you have to means write in your answer script. Okay. So we are left out with the second topic, which is the geometric transformation in 3D space. Okay, so the transformation consists of 7 topics, which are 3D translation, 3D rotation, and 3D coordinate axis rotation. Under this topic, general 3D rotation, coordinate methods for 3D rotation. Okay, and after that we have 3D scaling, composite 3D transformation, other 3D transformation, 3D reflection, and 3D shear, affine transformation, and OpenGL geometric transformations. Okay, so these are the topics which are present in the under the second chapter. Okay, so let's get started with the first one, which is 3D translation. This same as the things we discussed in the second module of 2D translations. Okay, just the matrix value will be a bit increased. Okay, that's all what is the difference. And yeah, that's all what is the difference. See, as you can see here, for the translation of the new matrix points will be passing the existing matrix points, and this is the new matrix multiplication which we will be multiplying with. So it will be transformed from this point to this point. That's about the 3D translation. Next, we can do it for all the points of the different objects, so the whole object will be transformed to different location. Okay, and this is the algorithm and code part. You can go through it later, but this is the inverse translation. If you want to do in the inverse translation, we will be using this one. Then we have the 3D scaling, the third topic. The second topic is a bit wide, that's why we will be discussing that at the end, but now it's just this 3D scaling here. Okay, so in 3D scaling, what happens is this is the new matrix generation by using this value here. We'll be just multiplying this one with this one to get the final matrix. Okay, so that's all what is there in the 3D scaling. And if it is with respect to the fixed point, what we will do, we will translate the fixed point to the origin, apply the selected transformation, and translate the fixed point back to its original position, same as we did in the 2D chapter. Okay, composite 3D transformation, a mixture of 2 or more transformation, is called composite 3D transformation, same as in the second module how we discussed. Other 3D transformation include the reflection. So means reflection will be as follows. If we reflect into the xy plane, it will be looking as follows, means it in this direction. If we reflect, this z will go in this direction. Okay, so for that also some matrices are defined: z reflect, x reflect, and reflection about the zx plane, and this is the reflection about the xy plane, this is the reflection about the yz plane. So these are the matrix values which you have to multiply with the original object, means the point values, so to get the where we have to reflect it, to which point we have to reflect. Okay, so that's what it is there in the reflection part. And the second one is shearing. Okay, the first one was 3D reflection and second is 3D shearing. In shearing, we will be modifying the size either with respect to x, y, or z. In 2D transformation, remember this was the shearing. If we apply the shearing in the x axis, it will become like this, and if we apply the shearing in the y axis, it will become like this, right? So that's what it is there in here also, 3D shearing. And after that we have the affine transformation. In affine transformation, we are just applying the linear means values of the a, y, and a, z, a, x, y, and z to the this function here, and this is the constant value which we are adding, so to get the new points. Here the length, size, and the angle between the different lines will be preserved. Okay, that's what it's that's what affine transformation means. You can go through it for more information. Okay, and then we have the OpenGL transformation functions. So you have GL translate, GL rotate, and applying for the 4:4 scaling matrix, GL scale we have, will be passing 3 values x, y, and z because it's 3D, and GL matrix, GL multiplication matrix to post multiply the current matrix by a specified matrix. And in the same way we have these functions, which is matrix mode, GL load identity. This was just how we discussed in the previous modules also. This is the same thing which is mentioned here. Okay, and get integer, GL get integer, push matrix, and pop matrix. Okay, so let's discuss the remaining topic, which is the second one, which I had left out while discussing this one. So that is a three-dimensional rotation. In three-dimensional rotation, there are 3 types of rotation, which is 3D coordinate axis rotation, general 3D rotation, and quaternion methods for 3D rotation. The last one is the most important one. Okay, so what's happening here is you can rotate the object with respect to x-axis, y-axis, or z-axis. Okay, so that's what the 3D coordinate axis rotation are. With respect to which axis you are rotating, that matters. Okay, so the homogeneous coordinate for the 3D z-axis rotation is this one. For the z-axis, it is this one, and this will be the points you will be multiplying with this matrix here. And in the same way, if you want for the x-axis, you will just interchange the x with y, y with z, and z with x as it's given here. And if you want to change it with y, you will do the same thing here. Just make sure that this equations you have memorized, and keep in mind, if it's for the z-axis rotation, z dash will be equal to z, and the rest will not have z in the terms. And same goes for the x also. and for y also. Okay, so you can go through it, you can find a similar pattern to memorize these formulas. Okay, then inverse also is the same thing, just apply the minus in the means relevant position for the each x, y and z axis, where you have to apply minus. That can observe carefully. Okay, so that's what is there in the first one, which is the 3D rotation with respect to coordinate axis. Then we have the general 3D rotation. General 3D rotation means we are not rotating with respect to x, y or z axis, but actually we are rotating with respect to an axis which is above the x axis, and means it's not exactly on the x axis. So what we are supposed to do is, first we have to transform this object into x axis, then rotate it, then again transform back into the original position. So translation, rotation and inverse translation, and again rotation we are doing. Okay, so translate the object, rotate the object, and inverse the perform the specified rotation, then inverse the rotation and inverse the translation. So that's how we perform, and that's just the brief overview. To get the more information of each step, what's happening, which matrix we are using, you can go through it. Okay, so here are the more information regarding these things, you can go through this one. Okay, so we will be using some matrix values for the specified operation, but that's the 5-step process which I just mentioned here. Okay, that's the brief overview, and actually you just have to explain these things in the exam paper, because in exam paper I didn't see any of the questions asked about the geometric 3D transformations numerical questions. Okay, so we'll be focusing much on the numerical, we'll be focusing less on the numerical type and just understanding what's actually happening. Okay, but make sure you memorize the matrix values. That's upon you how you memorize. Okay, next we'll also be looking at some numerical questions at the end of this topic. So what are the numerical questions that might come in exam, that we will be discussing at the end of this chapter. Yeah, so Coordinate method for 3D rotation is very important one. So in coordinate methods, it's an efficient method for generating a rotation about an arbitrary selected axis by using some quaternion units. Okay, so it has two parts, scalar part and the vector part. Q is equal to s comma v, and s is equal to cos theta by 2, and v is equal to u sin theta by 2. U is nothing but x and v is nothing but y axis. Okay, so by using these two values, we will be performing the rotation and the translations. Okay, then we have p of any point can be represented as o comma p, and the rotation of the point is then carried out with the quaternion operation. This is known as quaternion operation. Q p q inverse. Q inverse is s comma v inverse. It is the inverse of the unit of quaternion q. The transformation produces the following new quaternion o comma p dash. Before it was o comma p, now it is o comma p dash, and the new position can be calculated by using the dot product as well as the vector product by this equation, and this is the matrix form of the same, and these are the different equation which can be substituted back in the matrix. So we'll get this matrix here, and this complete the complete quaternion rotation expression is this one. R theta is equal to T inverse MRT, means you are translating and rotating again back, again translating back. That's all what is happening in the brief overview of the means, or the top view of the quaternion method for geometric transformations. Okay, mostly you just need to explain the theoretical concepts regarding the same, but sometimes they may ask the questions as well in the 3D geometric transformations. So if they ask the question what could be the question types is like this: a cube of length 10 units having one of the units as 0 0 0 and the 3 edges along the 3 principal axes x, y and z. If the cube is to be rotated about the z axis by an angle is given and the axis is also given. So first you have to consider rotation about the coordinate axis, and the length is also given, so you can find out all the points present here, and the angle is also given, and in clockwise direction is also given. Then calculate the new position of the cube. So what we will be doing is, before, when we had to find out the new position of the triangle, what we did, we applied the rotation for each of these points and then find out the new point, right? Same thing we will be doing here also. Here is the rotation by 45 degree and clockwise direction, so it's with respect to z. So we'll be using this formula, this matrix, and applying the cos theta value as z, I mean 45 degree, and we'll be getting this one. This matrix will be multiplied with all the other points. Okay, all the other points matrix will be multiplying this one, so we'll get all the new points here. Okay, that's the final position of the matrix. Same thing you can do for scaling as well. So here the question is, you can what is the final matrix which you will be multiplying for scaling, rotating and translating. You are applying 3 transformations, and the values are also given here, sx, tx and rotation angle. So anticlockwise is also given. You just have to multiply these 3 matrices and find out the final matrix. Remember, if you have points, you can use this points to use this matrix to multiply with the point to find out the final points, but the points are not given, just the matrix they are asked. So we'll just multiply the 3 matrices. This for the scaling matrix, this for the rotation, and this for the translation matrix. So we'll just multiply these all 3 to get the final matrix, and that's the final solution. Then the next question is problem on 3D transformation. Here also the same thing, you will just be applying the scaling transformations. Sx, Sy and Sz is given. Just find out the scaling matrix multiplied with the object values matrix, and when you do that you will get the final result, means where all it should be placed, means the points where all it should be placed. Okay, so this is the after scaled matrix. Okay, and yeah, this is old and new points, you can represent it in the table form as well. Then a rectangular parallelepiped has length as 3 unit and 2 unit and 1 unit on the x, y and z axis. Perform the rotation clockwise about the x axis. So the x axis is given, x axis is given to us, and rotation angle is given, and the rotation type is also given, 90 degree and clockwise. So we'll use this formula, and after that we'll be applying the for each point we'll be applying for x axis, y axis and z axis. The points are given to us, so its unit is given, so easily we can find out the points. After finding out the points, we'll be multiplying the whole matrix of the points with the this matrix. Okay, then it will perform the means the rotation, and the final points also we will get. Okay, and about the y axis, if they ask anti-clockwise, you have to use the y axis matrix, and then after that you will be multiplying with the respective points to get the new points. And here was the question: a homogeneous coordinate point. This is translated into x, y and z direction by this units respectively, followed by the successive rotation of 60 degree about the x axis. Find the final position of the homogeneous coordinate. So a point is given, it was translated with this tx, ty and tz values. After that it was rotated by 60 degree about the x axis, and it was the anti-clockwise because default is anti-clockwise. Find the final position of the homogeneous coordinate. So let's carry out the operations here. Tx, ty, tz, first do that. After we do that, we will get the means values here. So what will be the value? 3 minus 2, 2 minus 2 and 1 minus 2, those values we will get. After that we will be applying the rotation about the x axis. This equation will be applying, theta is given as 60 degree. So when we do the both operations and multiply it, means with this one we have to multiply the translation matrix values, and after that when you multiply you will get the new points values. Okay, so this is the third chapter, which is the elimination models. So well, let me show you what are the topics in the this chapter. See, the topics which are in this chapter are just an introduction to elimination models. Totally six topics are there. Okay, so among that the first one is the elimination models, a brief introduction, light sources, different type of light sources from where the light originates, and basic elimination models, ambient and diffuse reflection, specular and Phong model. Very important one, specular and Phong model. I've asked repeatedly in exams. I showed you in the beginning of this video. Also corresponding OpenGL function. What are the OpenGL function to implement that? What are the properties of light, and color models, RGB and CMY. This is very, very important, repeated one. Okay, so let's get started with the first topic, which is illumination models. So an illumination model is also called a lighting model. Okay, illumination means what? Lighting means brightening it. Okay, means coloring it. Those things are known as illumination model. Okay, so what model is used for doing that same activity, that is known as the illumination model. Okay, that's about the first topic. They ask you about the illumination model, you have to mention the same thing, a model used to illuminate the objects. Okay, that's known as illumination model. Light sources, an object which emits the radiant energy in a light form is known as light source, and it can have variety of shape and color, number of properties, different colors, and it can have in different type of intensities and the color components like RGB or CMY. So these are things you need to mention if they ask you about the light sources. And there are three type of light sources. First is the point light sources. In point light source means what? There is a point and light spreads in all directions. Infinitely distant light source means a light source is very far from that, the light comes in this way, like how it is for sun. That is known as the infinitely distant light source. Okay, and then we have the radial intensity attenuation. Radial intensity attenuation means as the distance increases, the light brightness decreases, right? So that is known as the attenuation, and this is the formula to calculate the attenuation. So you need not know about these things because it's just a theoretical concept and it's not asked much in exam. So just knowing a brief information regarding this is sufficient. Directional light sources and spotlight effects. What is directional light sources? Light source in a particular direction, and spotlight effect means a particular light for a specific purpose. Okay, that affects, what effects happen due to that. So this is what the light direction vector. If the light starts from here, it will mean spread radially in this way, and if an object is present here, it will be illuminated in this way, means whatever part comes from here, that will be illuminated till that part. And yeah, that's all what is there in the directional light sources and spotlight effect. How it affects, this diagram you have to make, and based on the distance and the angle, it will illuminate the object. Okay, Angular intensity attenuation, how it is dependent on the angle, means rather than the distance. First we discuss about the distance. As the distance increases, the intensity decreases, and how about the angle? As the angle increases, the intensity also decreases. Because why, like if you are standing at this position, the angle is too much here, but that intensity will be very less. The object which is standing here and the angles difference is very less, it will be illuminated very brightly, right? That's what the angular intensity attenuation is, and this is the formula for it. And extended light sources and the warm models, so wherever we apply the light, at that time that will be shaded. And how to know where we have applied the light, and what means which surfaces will be lighted, that is what is the extended light sources and warm model. So one model is a method that it provides a method for producing studio lighting effect using a set of point emitters with various parameters to simulate the barn doors, flaps and spotting light controls employed by photographers. So photographers have that studio effect, right? Like they will put a light here, but you can also means get the same effect by using some other point sources, extended light sources, which will be set in a particular angle in the direction, and using that also you can achieve the same effect. Okay, that's what the one model is. So that was about the topics, which is light sources. Okay, let's move on to the third topic, which is basic illumination model. So there are three basic illumination models, which is ambient light and diffuse reflection, and the third one is specular and Phong model. Okay, specular and Phong model. So let's discuss what is the difference between each of these. What is ambient? Ambient is produces a uniform ambient lighting that is same for all objects. What is diffuse reflection? Diffuse reflection means it will be deflected in different directions as the sunlight scatters the same way. That is known as diffuse radiation. So it is deflecting in different directions, and here is the formula which is given. You can go through it. As you can see here, this is the same thing here, same size, but this is standing straight, this is tilted here. Which is standing straight will get more radiation, and which is means tilted, that will get the less radiation. Okay, that's what the difference between the diffuse radiation is. And here are some diagrams and the formulas and the values, means how the value will change, then how the intensity will change. But the basic thing is that how much more means illumination you capture, that much will be brightened, right? That's what it's mentioned here. In the third one, the specular reflection in the Phong model. Here this diagram you have to means make and remember very carefully. L, N, R, V. What is N? N is the unit vector normal to the surface. It equals to the angle of the incident light. Okay, that is N, straight. And here we have the R, which is the unit vector in direction of the ideal specular reflection. In the direction of the reflection it is, and V is in the direction of the viewer. L is in the direction pointed towards the light source. L for light, N for normal, R for reflection, V for viewer. So in that way the reflection will happen means from a surface, that you have to keep in mind. Okay, and the angles are also different in between. So these are the angles between L and N, and N and R and V. Okay, so this is the specular reflection model. And the bright spot, and we can see on a shiny surface, is a result of a total or near total reflection of the incident line or concentrated region along a specular reflection angle. Okay, and an empirical model for calculating the specular reflection range. See, a model for calculating the specular reflection is known as Phong specular reflection model. Okay, and here what we have is it is directly proportional to the intensity of the specular reflection cos ns psi. Okay, and angle psi can be assigned to the values 0 to 90. So you can go through these concepts, but the main thing what I told you is just this one. Okay, if it is a shiny surface, it will be very small, like it will be means very concentrated, and if it is like spread across, then it is a dull surface, because the light will be spreading across different direction, and each point will be very less value here, but each point will be very high value. Okay, so that's what we are measuring. Based on the angle, we are measuring what is the intensity which you are getting and the specular reflection, and for doing that we'll be using some formulas, and that is included in the Phong model. Okay, so if they ask you about the Phong model, you have to mention these points along with the relevant diagram, and means these letters. What do these letters mean? You have to mention these letters here and explain. Okay, that's all what you have to do if they ask you about the Phong model. And plots of cos power ns psi using 5 different values for the specular component ns. So this graph shows how the n value changes and the graph changes. Okay, if n value is like 1, that time this is the graph. N value is here like 8, this time this is the graph. If it is 64, it is this like this graph. Okay, so it's becoming slimmer and slimmer, means more intense. Okay, more intensity, the more slimmer it is, the more intense it is. Okay, and for the different means for the greater angles it will not be illuminated. Why? Because for the greater values it will become concentrated, and for the higher values, like for the higher theta angle, here nothing will be visible. Okay, so that is what's mentioned here. And it can be for the different objects also, different objects, different values, like gold, silver and dielectric glass, there will be different values, and here is the angle, and this graph represents the intensity of the light. In the same way, if you go through this concept, you will get to know exactly what they are talking about, but the brief overview is just that what I told you. Okay, so this is very important question for exam point of view, Phong model. Okay, so let's move to the next topic, which is the OpenGL illumination functions. So to point light source function, will be using GL light, and you can enable or disable the light, and specifying an OpenGL light position and type. For the position and type, you will be using GL position, and will be supplying the values here, and here will be using the enable and disable, what light to be enabled, what light to be disabled. Specifying OpenGL light source colors, you can have ambient, diffuse or specular, and what color you want, that will be specifying here, black color, white color, that will be passing along with these values. Specifying the radial intensity attenuation, how much attenuation should happen, that is specified here. OpenGL light sources spotlights, so to get a spotlight effect, we will be using GL spotlight direction, GL spot direction, and to get the global lighting parameters, you will be using GL light model, and to give the texture, you will be using GL separate specular color and GL light model and color control. So you can just go through these topics and you will get to know what these topics mean, and some of the key points which you have to keep in mind is what do these means. Just to eliminate what are the functions used, basically they have explained that. Okay, if you go through it once, you'll get to know. So for this topic you pay like 60 to 70% attention, but for the next topic, which is colors model, this is very important, pay 90 to 100% attention for this one, because colors model, RGB and CMY, this is I guess it's CMY or YMC. So this is asked very much, means more than like at least if you consider the previous 10 papers, at least in 8 papers it is asked. Okay, so that's why it's very important. What is colors models? What is properties of light? It's electromagnetic spectrum, this we already know what it is, and it has the psychological color characteristics of color, brightness, purity, saturation, chromaticity, and this is for the different colors, what are the different frequencies, energy, and color model. This is very important. Color model, their primary color and the complementary colors. Complementary colors means using two colors will be producing a third color, that are the two complementary colors. Intuitive color concepts will be having the shades and the tones by setting the intensities of the colors, that is shades and tones. Now coming to the RGB model, this is the first model, and second one is, I guess it is CMY. Okay, CMY model, that are the two models you have to explain. So if they ask you about RGB, first you have to explain what. See, the question can be differentiated between RGB and CMY. So the first thing what you have to mention is what is a model, why we are considering this model, color model. You have to explain the properties of light, and after doing that you will be telling there are two types of model, RGB model and CMY model. In those two topics you will be mentioning the same points, just the values will be different, right? So what you will be mentioning is what is RGB. RGB means red, green and blue. Why we are using red, green and blue, that's the second question. In that you have to mention, because the human eye is means in that way, like it has the according to tri-stimulus theory of vision, our eyes perceive colors throughout the simulation of three visual pigments in the cones of the retina. That's why we are using R, G and B. Okay, so these are some of the information given. You can go through it and memorize the values here, like the wavelengths are given, you can go through it. And the three primary colors are red, green and blue. After that you have to draw this cube here. Cube is very simple, just draw a cube here and write black here and make a diagonal and write white here. Then it is RGB, right? Make one as R, another one as G, another one as B. RGB. Okay, now you only tell me, if you mix red and green, what will happen? Yellow. If you mix blue and green, it will happen cyan. If you mix red and blue, it will be magenta, right? That's what you have to mention here. And the values also easily you can mention. What are these values? 1 1 1 0 0 0, this is 0 1 0, z x, y and z values. Okay, after you have made this cube, you will be good to go for the next part. And here are some of the theoretical concepts, like the primary colors RGB, what is the parameters assigned, and the assigned ranges from 0 to 10. So you can go through it to get the more information, but a brief overview of what this concept is, just that. You have to mention what is RGB and why you have used RGB, what are the different frequency values, and the color model. Okay, so that's all what you have to mention in the RGB model. Next, coming to the CMY model. In CMY, it's the reverse of RGB. First we will have here black and then we will have a white. The most important key point in CMY model is the subtraction colors. Subtraction colors means what? This is the reverse of it. First we had here RGB, right? Red, green and blue, and in the this part, in this part, and this part, what we had? Magenta, yellow and cyan. But here it is reversed. So this is just the reverse of the previous model. So whatever you mentioned in the previous model, just mention in the reverse form. Okay, that's all what you have to do. Here if you mix all the colors, it will become black, because subtraction values, it will remove all the colors. If you do not have any color, it will be white initially. So that's the reverse of the previous one, CMY model. Okay, so transformations between RGB and CMY model. Okay, this also asked once or twice. So how do you get the CMY model? Is subtract 1 and RGB. So you'll get CMY model. If you subtract 1 from CMY, you'll get RGB here. Okay. So yeah, that's all what you have to mention, the transformations as well as the color differences, and that's all what is there in the module 3. Thank you so much for watching. I'll see you in the next one.